And happy Sunday. This is PFG Live. Welcome. Carl Tauber is checking in from the People's Republic of Rhode Island, reporting 57 degrees and cloudy. Welcome, sir. He says it's his favorite third world country. Let's see. Who do we have here? We have many people. So this is the podcast that asks, what are you doing indoors all the time playing with machines? Let's see. DBX is reporting from White Plains. Temperature, let's see. We'll give the full report. At 1756 Zulu, winds are 080 at 10 knots. Visibility 4 miles. Light rain and mist. Overcast at 300 feet. Temperature 09, 2.08. Altimeter 3017. And he confirms it's going to be blowing 60 miles an hour later today. Protium machining way off in the desert is 66 degrees Fahrenheit, 14% relative humidity in the parched desert. Smith of all trades reporting in at 56 degrees Fahrenheit, 94% humidity in the Raleigh. Evils is reporting in with his homegrown temperature 19.1, dew point 7.8, relative humidity 45.9, altimeter 1033.76. That's millibars, folks. And he says in remarks, there's got to be a more appropriate format. Jumping over to YouTube, we have CJ Stevens checking in at 58 degrees, 77% humidity on the farm here in East Tennessee. David Taylor is with us, David C. Taylor, 6 degrees and not very Christmas-like near Toronto, right? It's crazy. Robert Simpson is here, 46 degrees Fahrenheit and raining in southeast Michigan near Detroit. Let's see, jumping back. Tuck reports 100% participation. Precipitation. Cloudy, 49 degrees Fahrenheit in the Buffalo of New York. Widgetworks is with us. -3 science, 59% relative humidity in the Edmonton of Alberta. Canada, the land of amazing international shipping, the subject of our topic today. Carl says, we have gorgeous scenery, a charming but illiterate population, and politicians who will steal the smoke at a barbecue. That's true. And seafood. Ugly Skull is with us at 24 degrees science, drizzly, visibility 17 kilometers in Philippines. Welcome aboard, sir. Nice to have you here. Scott M. is with us from Peoria, Illinois, one of the best names of anywhere. 43 degrees Fahrenheit and raining. And we're getting definitely some rain all over this here country and that to the north. Almost Machining reports 70-something and sunny in near Peoria, Arizona. I think that's the other P, sir. You might want to check your P. Let's see. Welcome to everybody in Discord, which includes but is not limited to Tuck's Garage, Almost Machining, Scott M., Carl Tauber, Evils, Widgetworks, Smith of all trades, Paul Morley, Protium Machining, and DBX. So welcome. Let's see. Ugly Skull. Where in the Philippines? Well, give me a city, a town, something. Give me something to work with. Anyway, welcome aboard. It is a gray Sunday here. We're near Manchester Airport, which is reporting at 1853 Zulu. Winds are variable at 3 knots. Visibility 10 miles. Overcast 1,400 feet. Temperature 09. 2.05, altimeter 3028. Remarks, unimportant. Flatlapper has made it. Howdy. 39 degrees and cloudy, 10 miles an hour worth of the wind in northern Illinois. I think Illinois might actually be the winner today as far as population reporting in. So, yeah, good to see everybody. I was teaching Taekwondo last Monday, and I think it was last Monday, and we have 2 Mondays ago, And we have these two young kids that typically show up at the same time. And Mondays are pretty light. So I'm working with these kids, and I ask them a question, and one of them starts rattling off some made up stuff. And I said, stop. If you don't know something, what should you say? And the other one says, I don't know. And I'm like, exactly. That's the second most important phrase in all of science and engineering. I don't know. To which one of them says, well, what's the first most important phrase? And I said, hey, that's weird. So I want that on a t-shirt. I don't know. I bought a book because the title of the book was We Have No Idea. There you go, Tuck. That's interesting. There you go. That's why I bought a concrete saw for my grinder. Hey, that's weird. We'll see what happens. Exactly. Protein Machining says, arguably one of the most important things to be able to say as a human or an engineer, which, is separate and distinct from being human. Well, good morning. It is December 17th, and it is not cold out. Currently 48 degrees at my house and 83% relative humidity. So it's a weird December, but we will endure. The end of this day, Sunday, and into Monday, we're supposed to be getting a nor'easter. Bunch of rain. Nobody knows what it's going to look like, but we'll find out. We have a couple of topics to talk about today. The top of which is the debacle of shipping stuff. In my case, it's PFG stones over the border to our friends to the north in Canada. And in Canada, I could drive there. I could literally be there in 3 hours. And maybe not to my customer's house, but definitely to the border. I could bring a cardboard box and hand it to David. Did David disappear on me? I think he did. And we were just having the worst time. So I have two customers in Canada who recently ordered stuff, and the Evil says correctly, in shipping, only the bureaucratic distance matters. Exactly right. Which in this case is like 100,000 kilometers. Sorry. Oh, you're still here, David. So David and another gentleman ordered stones. They went off to Canada, and they paid. What was it? Import duty, provincial taxes. What was the third one? Brokerage fees. And this was all because I got convinced that UPS, are you listening, UPS? UPS was the way to go. Well, I am really pissed off about the whole thing. So we've dropped UPS to Canada. Okay. I thought I was going to keep one of the rates, but I decided to drop it all. So UPS to Canada, you're fired. And now we're shipping in consultation with our Canadian customers. We're shipping USPS, United States Postal Service. Carl asks, have you considered asking Grimsmo to be a Canadian distributor? I have not, nor do I think, except for getting good deals on stones, which he really likes. Yeah, I don't think he'd want to do that. I don't know that I want to deal with distributorship. I had another company approach me about being a distributor. And I'd like to hear back from them. You know who you are. But no, it's sort of a overcomplication. I think we figured things out. David Taylor says UPS charged $70 brokerage fees on top of all the other stuff. UPS, you should be ashamed of yourself. So UPS to Canada, you're fired. We're using USPS. So then I sent a package to David, and I sent a second package to David. Both exactly the same size boxes. Admittedly, the second one, which was a second order, for which I thank you, and some other goodies. They're a little lighter box, but basically same size box. So the first one went UPS and is arguably the last UPS shipment I will make to Canada. And then the second one is USPS. Now, let me tell you about USPS. United States Postal Service seems to have contracted for international, and in particular, we're talking about Priority Mail International. They seem to have contracted with a company called Global Post, which is amalgamating orders for export and then shipping them, in containers, whatever. I don't know how they do it, but they're dealing with it. Now, from a shipping point of view, here's something you don't know, or you might not know, is that when I ship, for example, UPS International, I have to put paper on the side of the box, which is the shipping invoice that meets customs criteria, that has a bunch of stuff on it. So I literally have to put paper on the side, on the side of the box. Global Post does it electronically, which from a shipping point of view is kind of useful. So when I packed up David's box, breaking news, this just in from New York City, breaking news, the New York City Public School Holiday Fair maze is currently being demolished by young children. Oh, the humanity. Film at 11. Thank you. That from Unix Carbide, man on the scene. Thank you very much. We don't have any live video for you, but we might have some later. And I see Unix has joined us in Discord. Unix, if you pop up with live video, I will get you in here, but no pressure. So I go to ship something on Global Post, either implicitly or explicitly. I'll explain what that means in a second. And the customs information gets sent electronically. I don't have to adhere dead tree carcass to the side of the box. So it's kind of nice. Now, it's a little alarming because somebody in Ontario who just ordered stuff. I print out a label, I slap it on the box, and it says New Jersey. Okay? It's a little disturbing when you see New Jersey pop up when you had Canada on your mind. But what happens is it goes down to New Jersey, goes to a sorting station at Global Post, it gets packaged up, and off it goes across the border. It has worked pretty well. I think it takes a little longer than we kind of wish it would take, but it's been smooth. However, I do this research. Here I am, kind of, upset about my neighbors to the north. It's like, I'd like to get you your stuff, but I can't get it any faster. Sorry. I'm so sorry. So I find out there's this thing. And let me see if I can get this up for you here. It's called here it is, DDP, Delivered Duty Paid. So if my shipment to Canada goes by Priority Mail International by the United States Postal Service, which goes via Global Post, I know this is getting complicated. If it's under $500, which all of my stone order, if you order a single set of stones, it is. And if it's under 4 pounds, it qualifies for a program called DDP, Delivered Duty Paid, and it costs $9.95, and you're done. Now, this almost sounds too good to be true, but apparently it's true. So that's what's going on with our shipments to Canada. By the way, if you're watching the video, in the Discord chat is pictures of a cardboard carnage happening down at the New York City Public School Holiday Fair. By the way, I am a product of the New York City public school system, which explains a lot. So I'm really pleased that we have this loophole that we're going to be using for Canada. I am hurt that my Canadian customers have spent money that I wish they didn't have to spend, and I truly apologize. And as a penance, now through the end of the year, if you're in Canada and you're ordering anything from the KP store, it's 15% off. And I'll give it to you on audio. I don't want it to be picked up on video, but the code is Canada15. Canada15 is the discount code if you're in Canada through the end of the year, as a way of saying sorry. I'm really sorry. So that's the good news for Canada shipping. That information is on our shipping and payments page, so you should be able to find that. So that's actually kind of good news. Like I said, I wish we knew that before, but we know it now. So that's DDP, delivered, duty paid. Now, here's the thing I don't know, and again, my Canadian friends are going to have to help me here, and whoever is the next Canadian placing an order that fits these criteria does that also take care of your provincial taxes? Does that not slow your shipment down? Does that really lubricate the process? The answer is I don't know, but I hope it does. So if any of you, my friends in Canada, have anything to say about that, I would love to hear from you. So that's if you have your own stories about issues with duties and other payments for shipping international and ways of solving them, I'd like to hear it. It's been the worst shipping problem I've had so far. And then when I posted this on Instagram, I got all sorts of comments back from the knife makers saying, oh yeah, shipping knives across the border is just a nightmare. And et cetera, et cetera. So I don't think I'm alone in this regard. It should be easier. But when we start a business, if we're going to be operating, internationally, and yes, Canada is internationally for us, even though I could drive there, right, and get some back bacon and maple syrup. We have to address these things, and I don't think I've spent more time on any single country and its shipping problems than Canada. So there you go. So we'll keep you posted on that. We have 2 experiments out. Whoever the next order is that uses DDP is experiment number 3, and we will sort it out. I joked that it would be cool to have a shipping expert on staff, meaning like Upwork or part-time person, that I can ask to help with these sort of problems. So if anybody knows anybody that is an international shipping expert that wants to be on call and offload some of these duties, let me know. So last week, I posted some pictures of this ruby stone that Tuck gave me. It's actually his brother, and wants it flat ground. Now, normally I don't do J-random material because the material matters and it's a whole new process. But in this case, I was really curious. So I said, sure, send it up. So it came up, fortunately or unfortunately, with a significant chip in one of the corners of this ruby stone. I've shown pictures of it before, so I'm not going to show it now. But I decided in consultation with my clients that we're going to cut off the end of the stone to get rid of that chip section and then proceed to grind it, which led me to wonder how I'm going to do that. So Carl says, what is a ruby stone? So thank you, Carl. These red stones that are very dense and very obviously hard, the most famous of them on the market right now is from Degaussett. And if I'm pronouncing it wrong, you could yell at me. They're very expensive. There it is. Degaussett, not Degaussett, because that's magnetic. Degaussett. Thank you, Evils. And they're They're very ruby red, which is why we call them ruby stones. But it's just another oxide. No, yeah, Carl, it's degusset. So Evil says it's sintered alumina with chromium doping. It's actually ruby. Yeah, it is actually ruby, but you had me at alumina. So, alumina is aluminum oxide. Aluminum oxide is what we call a white wheel. It's the most common abrasive known to man. We use it everywhere. And then we start adding little herbs and spices, and we start calling it other things. So if we make a nice transparent crystal for my watch, we call it, what do we call it? Come on, anybody? You know what that's called? That nice hard see-through material? Sapphire. Protium got it. We call it sapphire. We add a little bit of chromium, a little pinch of chromium, and it turns red and it's beautiful. We call it ruby. Interestingly, the stuff that they use in water jet cutting, which is garnet, is different. It's also reddish, but it's not aluminum oxide. It's actually a little softer. But all of these families of abrasives are mostly aluminum oxide. So that's what the ruby stone is. It's alumina with a little pinch of chromium. And you could argue that there is a different mechanical behavior due to the chromium, but fine. So that's what. There we go. Carl says densified alumina is used for the envelopes of high pressure sodium lamps. It is translucent. Excellent. Yes, Evils correctly points out that the most important thing here is that there's no binder. So if you look at the traditional material that I make PFG stones out of, by the way, this program is sponsored by PFG Stones. If you need to get flat, it's where it's at, pfgstones.com. So if you look at that material, it's chunks of, here's a chunk. Okay, if you're watching the video, you're in luck. Here's a chunk. It's a chunk of aluminum oxide and another chunk of aluminum oxide surrounded by essentially something that's going to glassify, that's going to melt and bind it all together. Okay? Carl says you need a jingle. Dude, that was the jingle. That's all we're getting today. So the ruby stones are alumina, sintered, I believe is the correct term. Yeah, sintered. You said sintered, and it is solid. There's no interstitial binder, so it's very hard. Okay, I'll work on it, Carl. Carl says I'm the bass player. I need to come up with the jingle. So it's an interesting stone. I am not. I have another customer. Hang on. Little treat if you're watching video. I'm not going to name them, but they are looking for a replacement for this 1/2 inch by 1/2 inch, 6 inch long black stone, very fine, which I think is the same material, but I haven't chemically analyzed it. So we're looking for a solution for them also. So we need to cut this stuff. Oh, I was going to say, I'm not representing any particular use for the ruby stones or the degusset stones, which is, their trademark, or the stone I just showed you. But people want it, and I'm trying to figure out how to cut it, how to grind it, etc. So I started looking around for a saw that I could put on the grinder to cut these things, akin to, flat lapper. He says, wait, no binder? Yeah, the alumina is sintered, which means, by definition, it means they squish it together under pressure and high heat, and then you're done. And then they slice it up. I have other samples of alumina, just so you know I'm not sitting around here, you know. I've been talking to another company that makes alumina, and if you're watching the video, here's a couple of little alumina discs. One is 99.7% alumina, and one is 96% alumina. What the other stuff is, I am not 100% sure, but it is sintered, and these discs are pretty nice, but they're not finished. So I'm looking at, actually that was for a different project, but it's all alumina. So, yeah, okay, so Evil says, sintering is what happens to clay when fired into ceramic. The particles get hot enough to stick together, but they don't melt. That black stone could be boron nitride. I don't know yet. We're working on that. It's a mystery. Flatlapper says there is still a binder, but a very low, he didn't say very, a low percentage. Okay, I'll buy that. But it is definitely not a bunch of beach balls with Elmer's glue between them, which is what your typical stone is. So there's a bunch of things that happen when you make it that way. You don't have pores anymore for the material that you cut to go into. That's one thing. The other thing is that the pressure is reduced because you've theoretically increased the surface area over which you're applying the pressure. Therefore, the pounds per square inch goes down. So I thought, oh, we need a tile saw, but I didn't want the square footage in the shop for a tile saw. I've covered that before. So I wanted a saw that I could put on the grinder. So I went to the Amazon, the river, and I looked for a saw. Let's see if I have a picture of it here. And I found that's a video. Stand by. Here's an artistic rendering. I found a saw that's intended for use on concrete, which sounds horrible, but it's pretty interesting saw. So I modified it to mount on a grinder hub, and we're going to try that as a saw for this material. So I did that, and then I'm like, yeah, it's kind of 100,000ths of an inch, 2.5 millimeters wide kerf. So I'm not sure if I'm going to like it, but it's the first one I got. So I may run over to Home Depot today and take a look at more blades, and maybe get a few more and drop the 1.25 inch hole in the middle to make some more saws, and then do some experiments. One of the things I was thinking, and I woke up this morning, I was telling Almost Machining this during the pre-show. I literally woke up this morning thinking about how that wheel is going to go through that stone, and I was worried about it chipping out and flying off and such. So I think I'm going to take the stone and I'm going to mount it to a substrate, which could be a piece of plastic, it could be another stone, it could be, I don't know what, so that when it cuts through, nothing happens. Like nothing's flying off. And that might be a good way to do it. So if anybody has experience in cutting this stuff, and I know there's people that do, let me know. Give me some input. I'm interested to hear what you have to say. Flatlapper says, lapping and some grinding attacks the weaker bond or the lattice of the binder. Yeah, understood. In fact, and Evil says the backer should be about as rigid as the material to offload stress on the cutoff piece, ? Essentially, that's what I'm thinking. So we might strap it to a another piece of stone. It would be about right. We'll see what happens. But I don't want, so this is not going to become part of my process. At least I can't see it. I do. It's exactly what I was thinking. He says, a sacrificial PFG stone? Yeah, actually, that is what I'm thinking. I don't have a lot of scrap, but I could probably use something to support it. We'll figure it out. So I don't want this to become a new process as far as production is concerned. But I do want the tool in the toolbox so that I could do these things. And I have another customer who you guys probably know. I'm not going to mention Grimsmo's name, but yes, I can cut a long stone into 2 short stones and make some other size stones, but I don't want to do that as a rule, as a standard product. Carl says, my understanding is that it is near in properties to monocrystalline alumina. Should be interesting. Tuck says, will you make a tiny PFG stone with the leftover piece so you can condition the stone? Jury's out. We'll see. We'll figure it out. So let's see what happens. So I think I'm going to make this a bit of an experiment. I'm going to get a couple of other types of saws. Now, all of these saws have diamond embedded in them. That's the whole point. This is a diamond saw. So the diamond is doing the cutting because the diamond is harder than the aluminum oxide or the sapphire or the, ruby, or pick your poison. And they're amazingly cheap. So, like I said, Home Depot, and you're done. So I may run up to Home Depot after our broadcast today. Paul Morley says, interestingly, rubies are used in watch movements for the low friction holders for the gear axes. Very cool to see how we, humans, have figured out how to use the material for such diverse use cases. Excellent point, Mr. Morley. I've taken to watching some of these watchmaker videos, as obviously you have too. And in fact, you frequently hear in watches, you'll see it right on the face. It'll say 17 joules or 25 joules. And those joules they're referring to are rubies. And there's all sorts of good stuff on YouTube. Robert Simpson says also fancy indicators. Yeah, so an indicator is just another example of a watch movement, isn't it? Taunus Mechanics, welcome, sir, says a proven process for degusset is to drop it on the floor. Yes, that will modify the stone in a predictable and simultaneously unpredictable way. Carl says, I'm not sure you need the serrations of the concrete saw since you're not cutting through big chunks of aggregate. Well, I know. And that's kind of where I was at when I got it. And I'm like, maybe, maybe not. But now that I have this set up on the Bridgeport for boring that center hole, and it's still set up, I might make 2 or 3, more saws, and we'll test them. What better way? Remember what Werner von Braun said when he said, a test is worth 10,000 opinions. So we'll give that a shot. But I am looking for people who have experience with doing this, because I don't know what I'm doing. My requirements are that it be a grinder saw. It go right on the surface grinder, so it doesn't cost me any square feet in the shop for another tool, especially for the infrequency of using it. Okay. Hey, thanks for the picture, Paul. I keep staring at that. DBX posted a picture of a bag of joules. Oh my gosh. We have to talk. Yeah, Evils points out that Ruby, another application of Ruby includes thermal stability in TIG torch ends. Really? I don't think I've ever seen that. And he says, I suspect its thermal conductivity is also a reason to use it. I would also imagine that it has very high thermal conductivity. Carl says, does your grinder allow speed control? The answer is yes. I can go down to, I think, a low of about 600 RPM under control on my grinder. WidgetWorks. And WidgetWorks, by the way, inspired me in part when he posted a picture of a modified saw on a tool holder. He says, as someone who has cut a crap ton of alumina with wheels, the serrated blades work best as it will flush faster, as any loading will wear out the nickel binder and the diamond falls out. So, understood, and we'll see what we can find. I've seen pictures of non-serrated blades. In fact, Stefan was showing us a picture of a non-serrated diamond wheel. I guess we can call it a saw or a grooving tool, and I'm sure it was for light duty. So we'll see what happens. So yeah, we'll have to mess with speeds and feeds, of course, and Carl correctly points out that I might not want it running at the speeds that I normally grind, but we'll find out. So it'll be fun. It'll be a good experiment, and I will report back, I promise. So that's the story. I haven't touched the wheel or the saw to the Ruby Stone yet, but that's coming, and we'll see what happens. Good job. Thanks for your input, guys. I appreciate it. I'm looking over the Discord server, and Almost and WidgetWorks seem to be typing furiously, so I don't want to go off the topic yet because I think they're about to come in with something brilliant. As predicted, Almost says, used for cutting carbide off. Hacksaw would work for the stone. May need to swap the blade and the cut won't be smooth. Yeah, definitely not doing a hacksaw, but that's okay. Yeah, I've done some carbide cutting with diamond stuff, but not a lot of it. So having a diamond cutting tool for the grinder in the toolbox is going to be very useful. And Carl advises to start slow. Not only will I start reasonably slow, but I will also be under flood cooling the whole time. And from my experience in grinding the PFG stones, flood cooling is really good for getting the swarf out of the way, especially when you're grinding a stone. That swarf is not like steel where it's shooting out like a bullet, and you have to help it by washing it out with the flood or air or whatever. But I think that's pretty important. Flat Lapper says, if this was a Diabond resin bond, I would shoot for about 5 psi at full cut. So I don't know what I'm definitely not going to be playing with a resin bond for this, but I understand what you're saying. So these diamond saws obviously are metal bond, but they're also pretty skimpy on the diamonds. I will consult with you further as we get closer, Flat Lapper. We'll figure it out, but it'll be interesting. I just want a no drama way to do this. And there's a lot of ways to get drama in doing this, so we'll find out. But yes, I can control from about 600 RPM up to 3600 RPM, and I can go up to an 8-inch wheel. 7 inches is comfortable. All right, cool. So that's the story on Ruby Stones. And that's my diatribe on why every time I say Ruby, I kind of like, let's just say aluminum oxide. But we can't. So earlier this week, I received a message from our good friend, Aaron Walla, who couldn't be with us today. I did talk to him. And Aaron is a very fine machinist and tool maker. And he is building a shop right now in his garage. Beautiful work. He has a grinder and he's about to add a second grinder. Well, he scored a second grinder and it came in and surprised him a little bit in that it was wired for 460 volts. Now, this is not uncommon in an industrial scenario to have a 460 volt machine. And if you think about it, and actually, even if you don't think about it, the higher the voltage, the lower the current for a given power. So you can get away with less copper, and if you have an industrial environment where you have many machines, the higher voltage directly leads to a lower cost of the physical plant installation. So 460 volts is not an uncommon voltage. If you now, I'm an electrical engineer, but I don't, I'm not a power engineer. But I'm comfortable with all this stuff, and I recognize that a large part of our engineering community, or I should say our machining community, may not be so comfortable with the electrical terms, so we're not going to take it for granted. But that's why 460 volt machines exist, and that's why 230 volt stuff exists in your home. Your hot water heater is not running on 115 volts. It's running on 230 volts. Same reason. Less current. You need less copper to get the job done. So Aaron gets his new grinder and very happy with it until he gets to the nameplate that says 460 volts. So I want to talk a little bit about why this is both a good thing and a pain in the neck, and what the solutions are. So DBX says Westinghouse was right. So yes, Westinghouse was right. That's a whole piece of history. I don't know if you know this, but there was a fight between Tesla, not the car company people, the person, and Edison, with respect to DC versus AC. And Tesla basically invented AC motors. And Edison was in favor of DC everything. And of course, you know who won out. Tesla won out. And Tesla licensed the patents for AC motors, which of course we now know them as three-phase motors, to Westinghouse at, I think it was 10 cents per horsepower. And at some point, Westinghouse came to Tesla and said, look, we want to keep going, but this contract that we have with you is going to break us. And Tesla ripped up the contract. He ripped up the contract. He would have been a trillionaire in short order. He ripped up the contract. So, getting back to where we're at. Greenwood AG, welcome, sir, says, I use a large transformer to step my 240 volt three-phase to 480 volt three-phase. A good suggestion. We're going to talk about that. John Youngquist, welcome, sir. He says, in Canada, we often use 600 volts for machines. Same reason. Absolutely. Also in Canada, you generate lots of hydro. So for you non-Canadians, hydro is short for hydroelectric power, and Canada makes a lot of hydroelectric power, for which I salute you. So back to our story. So here you are. You're a home shop guy, professional or hobby, doesn't matter. And you find yourself with a machine at 460 volts. What do you do? So our other good friend, Adam Demuth, yeah, Carl, you're heading off into history. He says he was putting the wood to Edison, his former employer. That's true. Let me show you a picture. Get the picture up. I was talking this morning. I called Adam Demuth because Adam found himself in a very similar situation. And I took a few pictures when we were talking. Here we go. And he had a machine that was 230, and he was running it on 230 directly. But then he got another machine which he thought was going to be 230. Tell me if this sounds familiar. And it turned out it was a 460 machine. In fact, it was his CNC Parker Majestic that came in, and it was a 460 volt machine. So he went through this, and here's what he did. And I'm going to argue, 330 volt. I don't even know where 330 volt comes from, Tuck. I think that's a European standard. It's just another one of those things. So I'm going to argue that the solution that Adam Demuth came up with, and I remember talking to him about this literally years ago when this was all happening, is a very good solution, and I'll make the argument why. You're not going to like the answer. Your pocketbook, your wallet, your checkbook is going to weep a little bit, okay? But in the end, I'm going to make the argument that this is the best way to go. So if you're looking on your screen, you'll see a bunch of boxes. The important box is the lowest thing in the picture. Adam had to buy chose to buy a single phase transformer from 230 volts to 460 volts. And that made 460 volts, more or less, of single phase power, which then went into a phase perfect phase converter, which made 460 volt three phase power. And that was delivered to his CNC grinder. And that's his setup right now. It works beautifully. Now, that setup, I think, is a perfect setup. So let me reiterate it. You're in a home in the United States. Homes in the United States have single phase power. So we get, off of the pole, we get 230 volts, okay? Off of the transformer at the pole, we get 230 volts. So I'm gonna if you guys know your electrics, you could go grab a coffee because you know everything I'm about to tell you, but some of you don't. So coming off the pole are three wires, okay? They are ground and then L1 and L2, so the two legs of 230 volts. So if you put an AC voltmeter between those two wires, it would read 230 volts. If you put an AC voltmeter between any one of those two wires and the ground wire, it would read 115 volts. Okay? That comes down to your main panel, at which point your main panel sets up a bus bar for ground and a bus bar for neutral. And for reasons that we're not going to get into, at that point, you now have four wires defined. You have L1, L2, right? There's 230 volts between them, ground, and neutral. And from your main panel forward, the ground is only used for safety ground, and the neutral is used for carrying current. I'm not going to get into why, not important. So you march up to your machines, right? And you have 230 volt breakers which if you look in your panel, it's 2 breakers stacked together because you're putting a breaker on both legs, L1 and L2 simultaneously. And then if you're running 230 volt machines, off it goes to a 230 volt machine very happily. However, if you're dealing with the conundrum that we're dealing with, here's what you can do. You can go with a pretty big breaker and go into a transformer that goes 230 to 460, okay? That will set you back, and I apologize in advance, I'm sorry, $2,000. But now you have 460 volts, single phase. Now you can distribute that to small VFDs, and I'm looking at you, Aaron, okay? And you could buy the same, let me show you a picture of a small VFD. Let's see. Turning off the slideshow. There we go. You can buy a VFD like the one on my Bridgeport. Here it is. So there's a Tico Westinghouse MA7200 inverter. They call it an AC inverter, but that's a VFD. That's what runs my Bridgeport. And you could buy these in all sorts of horsepowers. So you could get them from fractional horsepower up to many horsepower. And they're relatively inexpensive. So I think I pay, I can't quite remember, on the order of $200 for this 2 horsepower, I think, VFD. And that will turn single phase 460 into 3-phase 460, and off you go into a 3-phase motor. There's issues here, and I will explain the issues. If you go with a phase perfect like Adam did, and I remember when he was wrestling with this problem, a phase perfect is a power supply. You literally could take the 3-phase output from the phase perfect and run it to a bunch of outlets, run it to a power bus and run multiple machines off of it. Oh, Flingshot says, I am running a static phase converter for my Bridgeport. I don't want to go off the exit ramp here and talk about static phase converters. My recommendation is if you could possibly afford a proper phase converter, which I don't consider a static phase converter a proper phase converter, do it. Okay? A static phase converter is a hack. It's a hack that makes it kind of work. But you are not going to get power out of your motor at its rated horsepower. And it will burn up eventually. Those are 2 things I know about static phase converters. Getting back to it. So the difference between a phase perfect is a power supply. A VFD is meant to go on one motor. So if you're in the situation where you have that one motor you have to run at 460, you can come out of a 460 transformer, go into a 460 VFD, and you're done. Plus you have the features of the VFD. Flingshot, it will burn up the static converter. I've seen many static converters with burned up capacitors because they are depending on capacitors to run the power through, and they frequently blow up. Not blow up, but burn out. We could talk about static phase converters another day, but they're a hack to get. See, there was a need for a home shop to be able to run a 3-phase motor without a big investment. Does that make sense? A static converter makes the motor turn without a big investment, but your 3 horsepower motor is going to make maybe 1 horsepower. That's the difference. Greenwood says, I guess the grinder in question doesn't have motors that can be wired to the lower voltage. So that is an excellent solution if you can do it. there's two problems there. One is you could have motors that are simply not wired to run either 460 or 230. If you do, there's a box on the side of the motor. It's called a pecker box. I didn't make that up. And you are able to go in there and rewire your windings for one voltage or the other, unless you can't. So some motors will not do that. So I'm addressing the situation right now where you can't do that. Of course, if you can get away with that, you don't have to buy the transformer. You would just run 230 and go into a VFD, and life is good. So let me make the argument why getting that 460 volt transformer is a pretty good solution. Now, another one of our, John Youngquist said in Canada, we often use, was it John that said that? No, Greenwood AG says, I just use a large transformer to step my 240 volts three-phase to 480 volts three-phase. That is a very good solution. It's just a much more expensive solution. So, in other words, you make your three-phase at 230 volts, and then you go into a three-phase transformer that makes three-phase at 460 volts. That works really well. Yeah. Okay. So we'll get back to Kodo Hundo. Welcome aboard, sir. We'll get back to that later. Carl says rotary phase converters aren't expensive, but they don't do variable speed. Yeah, that's because they're power supplies. They're not VFDs. Big difference. If you don't need a VFD does acceleration, deceleration, variable speed, but it's meant to be on one motor, married to one motor. Whereas the Phase Perfect, which is a power supply, is meant to feed as many motors as it's rated for. Okay. Flatlapper says, perhaps just change the motor then. Well, here's the problem. You got a machine that's designed to hang on 460. One of the issues you're going to have is the electronics, and the electronics power supply also designed for 460. Because if that's true, you can't change that unless you go change the transformer or rewire the transformer in the machine. It's a bag of worms, and each situation is going to be different. Again, Adam the machinist, Adam Demuth, his solution was a more general solution, but it cost him $5,000, and that was a 460 single phase transformer, followed by a Phase Perfect 460 volt power supply, three-phase power supply. It's not a VFD, it's a power supply. He could now add a second or third machine and hang off the same Phase Perfect, and he's golden. Okay. This is a $5,000 solution, and I recognize that that's a lot of money, but I'm going to make an argument why this is a reasonable thing. If you're a home shop machinist or any size shop machinist, and you go to buy machines at an auction, for example, and I'm not a big fan of auctions, but I also recognize that you could find bargains there. You're going to pay less money per unit value on a machine for a 460 machine because there are fewer people that want it. Whereas a machine that runs on 230, every other home shop machinist wants it, which drives the value up. If you can handle 460 in your shop, you are able to get better deals on machines. So there's your trade-off. Spend a little more on your power plant, okay, so that you can handle 460, and then you're able to get better deals on 460 machines. Also, you spend less money on copper for the same reason 460 exists in the first place. Robert Simpson says he could also get 480 volt VFDs. Yes, but 480 volt VFDs are going to turn 480 volts into 480 volts three-phase controlled, right? So you still have to get the 480 volts. Here's an important point. A VFD is not going to convert 230 volts to 480 volts. To the best of my knowledge, I don't know of so-called boosting VFDs, but I wouldn't count on it. So WidgetWorks, I'm just translating what you said from the Canadian. He says, used transformers can be had for pretty cheap. My big grinder is 575 volts, and one of those transformers was a pain to find used, but I was still able to, and it was half as much as new. Yes. Yeah. So I looked here's the manual. If you're watching the video, I'm holding up a manual. Here's the manual for my VFD, right? And right on the front cover, it says you can get them in 200 to 240 volts, 380 to 480 volts, 500 to 600 volts. So they come in 3 different voltage ranges, and they come in horsepower leading from 1 horsepower to 3 horsepower in the 240 volt. In the 480 volt from 1 to 75 horsepower, and in the 600 volt from 1 to 10 horsepower. So you can get a VFD to do the motor control job in any of the voltage flavors. And they're all equally inexpensive. The VFDs are inexpensive. Now, here's the thing. If you have a machine that has motors and electronics, you can't feed the electronics side with the VFD. So every situation is going to be different. That's why I like Adam's solution, which is he basically set up a 480 volt 3-phase power source in his shop. So any machine that he brings in that does that plugs in and starts working. So in conclusion, Your Honor, there's a bunch of ways to address this. It can lead to being able to use cheaper machines or less expensive machines for a given value, and that's pretty cool. Transformers change the voltage. Power supplies or converters convert from single phase to 3-phase, and VFDs also convert single phase to 3-phase, but they only are meant to drive one motor. Filling Shot says my Bridgeport is variable speed. Could that work with a VFD without much hassle? So my Bridgeport, which I showed, is also variable speed because it has the variable transmission. If it's electronic variable speed, that's one question. If it's the continuously variable transmission, it's no problem. It only matters what the motor is. Okay. So this is kind of a big topic. Not everybody has to worry about this. In my shop, I run my vertical machining center off of a phase perfect converter, and I run the grinder off of a twin phase perfect converter, each of them 10 horsepower. And the reason I have 2 of them is a long story, but yeah, almost. Yep. Almost basically said, the bottom line of what Almost just said is Adam did good. Yeah. Yeah, Flingshot. So, like I said, that VFD, instead of your static phase converter, that VFD is going to cost you between 150 and 250 bucks. And it's worth its weight in gold because it's running one motor. It does acceleration and deceleration, ramp up and ramp down. It does overload protection. It does many good things. So if you've lived long enough with your static phase converter, I think it's time. It's time. It's a grinding spindle. So Flat Lapper says 230 single phase to 240 three phase. Use a 240/480 motor with a VFD. Update controls and power as necessary, unless this is a grinding spindle. Yeah, we're starting to get into the weeds here, Flat Lapper. But we'll help. We will pledge to help Aaron get his machine up and running with as much engineering assistance as we could provide. I will remind you, by the way, that the PFG stones, known as the 4-inch minis, are a result of Aaron's request many years ago for a small set of stones. So really, he is the father of the minis. So I wanted to show one last thing before we get out of here, because we're at the top of the hour. The schematic, I'm going to show it from my book here. The schematic, or the rough schematic for the VFD gives you a hint as to how it works. And the main thing is that the input to the VFD gets rectified to DC. That's the first thing that happens. Okay? It gets rectified to DC, and then the converter circuitry chops up the DC to make the three legs of the three-phase. That's why you could run it off of single phase or three-phase. It doesn't care. As long as you make enough DC, it'll affect the rating, of course. And then it chops it up and synthesizes the three phases going out to your motor. So it controls the vertical, it controls the horizontal, it does everything going to the motor. And that's why the VFD can do all this super nifty stuff that it does. It's also why it cannot convert the voltage. The voltage is what it is. That's the difference. Okay, this was fun. Evil says there are some voltage doubling VFDs. Yep, I could see that happening. A voltage doubler is a trick with capacitors and diodes. And again, that might work for one motor, but it's not going to work for many things. So again, my bottom line here is that I agree with Adam Demuth's solution as being the most general solution, and it will enable you to use machines that you can buy cheaper than other guys because they don't have 460. So I'm going to wrap that topic up, and thank you guys for listening. That was a lot. WidgetWorks says there's also VFD packages that have built-in transformers. I'm sure there are many things. I'm just trying to get Aaron on the air. So we'll figure it out. My Okamoto grinder comes with a big transformer. And the big transformer that it comes with, let's see if I can get you a picture of that. Yeah, here's a picture of it. The big transformer that it comes with will take 460 or 480, 460 or 230 input, and it will make 200 volts, three-phase. So my situation is I go into the phase perfect with 230. I come out with 230 three-phase. It goes into this transformer at 230. It comes out at 200 three-phase, which is the Japanese standard. And you could have made the argument, well, maybe it could run on 230, but you know what? I use the transformer. Everything's fine. And I'm not sorry about it. Also, the added advantage is no ice forms on the transformer. It is not perfectly efficient, and it does burn some power, which is absolutely true. Okay, so there you go. In absentia, we have vindicated Adam Demuth, and we have helped Aaron Walla. I want to point out that we have holidays coming up, and there is going to be a schedule change for the PFG.Live. We are not going to have a PFG.Live on December 24th, and we are not going to have a PFG.Live on December 31st. 1st. So PFG Live is taking 2 weeks off. We will see you on January 7th with the next PFG Live and maybe some surprises. I wish everybody an outstanding holiday season, and I wish you good food and good family, maybe not necessarily in that order, and we'll see you on January 7th. In the meantime, be nice, get flat, and stay flat. We'll see you on the other side. Take care, guys.